choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
Get my feet out. Okay, I'm out.
How does it feel for the United States to be the new record holder?
At last, huh?
When that baby lights, there's no doubt about it.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Houston, Tranquility Base here. The Eagle has landed.
That's one small step for man,
One giant leap for mankind.
Hello and welcome. This is Michael Annis, and you're listening to episode 123 of the Space Rocket History Podcast. And now, Apollo, astronaut selection and training. From the moment the lunar landing was proposed as the primary goal of manned space flight, NASA officials and outside scientists debated the qualifications of the people who would land on the moon. Scientists urged that at least one of the crew should be a scientist with enough experience to assess the significant features of the landing site quickly and accurately, and to collect samples with discrimination. Those responsible for mission operations and crew training insisted that mission success and crew safety could be assured only if every crew member were a skilled pilot, preferably a test pilot, able to complete a mission alone if that unlikely situation should ever arise. Once the many unknowns in lunar landing operations were better understood, it might be considered safe to take along a person with different qualifications. Finding crew members who combined the experience of a scientist with the skills of a test pilot proved impossible. For the first 5 years during the experimental development phase of the Apollo program, piloting experience took precedence over scientific training as a requirement for admission to the astronaut corps. Later, as missions devoted largely to scientific operations were contemplated, scientists were admitted and trained as pilots. Before Project Mercury, design concepts for manned spacecraft were constrained by a lack of hard facts about the human ability to function in the space environment. Many believed that electronic systems controlled from the ground or programmed for specific contingencies offered the only safe and practical means of operating a spacecraft. From this point of view, the person in the spacecraft was simply a passenger, an experimental subject whose main function would be to provide the physiological data needed to define the limits of a human's role in space. Mercury's designers did not completely agree with this philosophy. They conceived a spacecraft in which the pilot could take control of critical systems if necessary and would have some measure of control at all times. Within months of the start of Project Mercury, NASA selected its first group, aka Group 1, of pilots for the early Earth orbital flights. The Mercury 7 all-military test pilots with strong engineering backgrounds were volunteers picked from a list of more than 100 men provided by the Pentagon. In view of Mercury's experimental character, the choice of test pilots was appropriate. They were accustomed to dealing with emergencies under stressful conditions and were familiar with the physical and psychological stresses of high-speed flight in unproven aircraft. Here's the audio of the Mercury 7 introduction to the press.
Ladies and gentlemen, today we are introducing to you and to the world these 7 men who have been selected to begin training for orbital space flight. These men, the nation's Project Mercury astronauts, are here after a long and perhaps unprecedented series of evaluations which told our medical consultants and scientists of their superb adaptability to their coming flight. Which of these men will be first to orbit the Earth, I cannot tell you. He won't know himself until the day of the flight. The astronaut training program will last probably 2 years. During this time, our urgent goal is to subject these gentlemen to every stress, each unusual environment they will experience in that flight. Before the first flight, we will have developed our Mercury spaceship to the point where it will be as reliable as man can devise. We expect it to be as reliable as any experimental aircraft. It's my pleasure to introduce to you, and I consider it a very real honor, gentlemen. From your right, Malcolm S. Carpenter, Leroy G. Cooper, John H. Glenn, Virgil I. Grissom, Walter M. Schirra, Alan B. Shepard, Donald K. Slayton. These, ladies and gentlemen, are the nation's Mercury astronauts.
In choosing test pilots as its first astronauts, NASA came down on the side of people as active participants in space operations. It was yet to be shown how much humans could effectively participate, but the astronauts in the first group insisted on giving the pilot as much responsibility for control of the spacecraft as feasible. If the pilot did not operate the spacecraft, what was the point of a person in space, especially a test pilot? Most of the engineers in the Space Task Group agree with this viewpoint. In light of their long NACA experience with piloted aircraft, they too inclined toward giving pilots all the control they could safely handle. When Group 1 entered the program in April 1959, Project Mercury and the Space Task Group were organizationally in flux. As a result, the original 7 defined the role of the astronaut for the entire Apollo program. Administratively, they reported not to any project office, but directly to Robert R. Gilruth, director of the Space Task Group. For most of Gilruth's career in the NACA, he had worked with pilots, and he took a special interest in this group. Shortly after the astronauts reported aboard, he assured them that whenever they had a serious concern with any aspect of spacecraft design or mission operations, he would see that they were listened to. Given this kind of autonomy, the astronauts were considerably more than pilots in training to operate a new vehicle. While undergoing training, they also took an active part in reviews of the spacecraft design and operations planning, offered suggestions from the pilot's point of view, and contributed to the design of the flight simulators that soon became an important part of astronaut training. Each person was assigned an area of spacecraft systems or operations planning. For example, attitude control systems, communications, and recovery operations, as a prime responsibility. In the astronaut's specialty, he closely followed the developments and served as the point of contact between his astronaut colleagues and project engineers. Training was strongly engineering and operations oriented, a pattern that would be carried into subsequent projects. In 1962, scientists began lobbying for representation on Apollo crews. NASA's Scientific Advisory Committee first addressed the role of the astronaut in space at the Iowa Summer Study in 1962 concerning humans on the moon. The study reported the belief that, quote, It is extremely important for at least one crew member of each Apollo lunar mission to possess the maximum scientific ability and training consistent with his required contribution to spacecraft operations. This person should participate in the earliest possible lunar missions, and since the chosen mode of operation called for only 2 men on the lunar surface, the maximum scientific return will be achieved only if the scientist himself lands on the moon." End quote. A working group of the 1962 summer study considered in detail the role of people in space exploration, formulating an opinion that was known as the scientist position, with reference to science missions of many types, not merely lunar exploration. The group defined several combinations of scientific and astronautic skills that would be appropriate for different degrees of scientific participation in manned space programs. At the top of the scale was the scientist astronaut. Fully trained both as a scientist and as an astronaut, he could operate the spacecraft as well as make valid scientific observations. For the long term, the working group recommended creating an Institute for Advanced Space Study, a graduate-level institute with a unique curriculum in which candidates holding bachelor's degree would be trained as scientific astronauts. Meanwhile, aspirants to this position should be recruited from among qualified scientists and trained to achieve comparable qualifications as astronauts. The working group did recognize that no such scientist astronaut could be trained in time for a lunar landing within the decade. For the short term, they acknowledged that the best course was to give qualified astronauts as much training in science as possible, so that they could be useful observers for the scientists on the ground. These astronaut observers were expected to play a role in lunar exploration even after fully trained scientist astronauts became available. Others who would be important in conducting space science missions were the ground scientist, a scientist thoroughly familiar with all the details of spaceflight operations, and lastly, the scientist passenger, a scientist physically qualified for spaceflight but not trained to operate the spacecraft. Not surprisingly, this summer study report repeatedly emphasized the need for the scientist astronaut to keep up with his science. The scientist who does not maintain a continuous research program falls behind his colleagues who do, and loses his standing in the scientific community. At the same time, the tone of the working group's findings implied that the techniques of operating the spacecraft could be learned by any intelligent person in a couple of years, and were therefore of subsidiary importance. Next, the Space Science Board sent out questionnaires to a number of scientists to understand what the scientific community thought. One of the questions was, should the first scientist on the moon be an astronaut? This is the consensus of those responding. Quote, "Of course, he should be familiar with all aspects of the spacecraft and be able to take over in an emergency. However, his qualification as a crew member would not depend so much on his ability as a space pilot as on his scientific aptitude." End quote. This is the response to the question of how astronaut scientists should be developed. Graduate students or early postdoctoral fellows should be picked and trained for at least 4 or 5 years. They should go through astronaut training for part of each year to become familiar with the problems of spaceflight. It is hoped that this would not involve too large a fraction of their time, since emphasis should be on their development as scientists." End quote. In 1962, of course, few people fully understood the demands that would be made of Apollo crews. But if these statements reflected opinions widely held in the science community concerning the training required to become a proficient astronaut, it is not surprising that misunderstandings developed when the time came to choose crews for the lunar landing missions. The first group of astronauts immediately became public figures, and as Mercury shifted into flight operations in the closing days of 1961, demands on their time for interviews and personal appearances multiplied. NASA welcomed the publicity for the space program, but this aspect of the astronaut's status often made impossible demands on their heavy training schedule. And when a second program, Gemini, was established late in the year, it was clear that more astronauts would be entering the program, further complicating training and flight preparations. When Space Task Group managers decided that someone should be appointed to organize the astronauts' activities more efficiently, some of the astronauts suggested that they would prefer to have one of their own rather than an outsider in that job. As it happened, one was available. Air Force Captain Deke Slayton, assigned to the second Mercury orbital flight, had been grounded a few weeks before the mission when physicians discovered a minor, and as it turned out, apparently harmless, irregularity in his heartbeat. Although no one could definitely say that Slayton's condition would endanger him or the mission, neither would any medical expert assure NASA that no risk was involved. Prudence, a quality which NASA's high-level managers possessed in full measure, dictated that someone without any detectable abnormality should fly the mission instead, and Slayton was grounded until the physicians could be confident he was physically qualified to fly. Slayton was one of the most experienced of the original 7 astronauts. He had flown combat missions in Europe and in the Pacific in World War II, and had been a test pilot assigned to fighter operations at the Air Force Flight Test Center at Edwards Air Force Base when he was selected as an astronaut. His personal commitment to the manned space program was complete. He had vigorously defended the cause of humans in space before the Society of Experimental Test Pilots, when most test pilots, unfamiliar with the actual course that the project was taking, considered that Mercury offered them no future and little valuable experience. His disqualification, especially on physical grounds, was a shock to everyone in the project as well as to the public. It was personally devastating to him. Besides losing out in the competition for a space flight assignment, he was forbidden by the Air Force to fly alone in high-performance aircraft. In September 1962, Slayton was appointed coordinator of astronaut activities, and he reported to Gilruth. Without complaint, he took over the largely administrative duties of scheduling training activities, visits to the contractor plants, and public appearances and interviews with the news media. But the most important responsibility he assumed was that of assigning astronauts to specific missions. This responsibility he shared with no one else, although he had plenty of help in assessing each candidate's personnel and professional qualifications and mastery of the spacecraft systems and mission plans. Slayton made the final decision. His decisions stuck. In the entire manned program, from the later Mercury flights through the Skylab missions, he could later recall only one instance in which higher authority challenged his judgment. When the Manned Spacecraft Center was reorganized the following year, Slayton's position was redesignated Assistant Director for Flight Crew Operations, organizationally on a level with the Assistant Directors for Engineering, Flight Operations, and Administration. For some time, he was also Chief of the Astronaut Office, the administrative unit that coordinated training and other astronaut activities, and he continued training with the first two groups as much as he could, hoping for eventual reassignment to flight status. Under Deke Slayton, the astronaut office was run much like the military, which for several years it effectively was, since almost all the astronauts were or had been Air Force, Navy, or Marine officers. Slayton encouraged open communication between himself and the astronauts, but expected that when a decision had been made, the discussion was finished. As one of the astronauts characterized Slayton's management style, the astronaut's job was to do what the commanding officer says, and if you don't like it, you can leave the astronaut corps. Slayton well understood the position manned spaceflight occupied in the National Space Program as a consequence of its prominence in the public eye. He knew any failure, especially one that endangered or killed an astronaut, could set back the lunar landing for years and might even kill the manned space flight program. His contribution to avoid failure was to pick the best people for the crews, and as long as manned spaceflight entailed any hazardous uncertainties, the best people would be experienced test pilots. 3 of the Group 1 astronauts made it to the Apollo lunar program. Gus Grissom was assigned to Apollo 1, and that claimed his life. Wally Schirra commanded the first Command Service Module test flight, Apollo 7, and Alan Shepard commanded Apollo 14 and made it to the moon. While much was learned from Mercury, much more had to be learned before a lunar mission could be planned. Even before President Kennedy's decision to go to the moon was announced, Space Task Group engineers were planning the second phase of manned spaceflight. Project Gemini, approved in early December 1961, would test various techniques of rendezvous, determine whether men and systems could survive and function during long missions, investigate the radiation environment in near-Earth space, and develop techniques for controlled landings. 12 missions were planned, 10 of them manned, to start in the spring of 1964 and fly at 2-month intervals. Additional missions required additional astronauts, and on April 18, 1962, NASA announced it would accept applications for trainees. Once more, test pilots were given preference, but the required number of flying hours was reduced, and civilians as well as military pilots were eligible. The upper age limit was reduced from 40 to 35, and the education qualification broadened to include degrees in physical or biological science as well as engineering. A list of more than 250 applicants was cut to 32 by preliminary physical and psychological screening. After intensive evaluation in Houston, 9 new astronaut trainees were chosen in September 1962. There were 2 civilians, 4 Air Force pilots, and 3 Navy officers, including some who had applied for the first group but had not been selected. The trainees selected were Ed White, Jim McDivitt, Frank Borman, Jim Lovell, Tom Stafford, John Young, Pete Conrad, Elliot C., and Neil Armstrong. Selection of this group virtually depleted the pool of qualified candidates from the small corps of test pilots in the country, and it was the last group for which test pilot certification would be a requirement. The new trainees reported at Houston on October 1962 to begin a 2-year training course. A 4-day week was normally scheduled, the 5th day being reserved for public relations duties or for travel. After 2 weeks of orientation to NASA's organization and familiarization with the near-complete Mercury project, the second group and the first group started a 3-month basic science course interspersed with briefings on Gemini and Apollo projects and systems. The classroom work covered astronomy, aerodynamics, rocket propulsion, and the physics of orbital flight and reentry. It included lectures on computers, space physics, and the medical aspects of spaceflight. Almost 1/3 of the classroom time was spent on navigation and guidance. In mid-January 1963, the class flew to Flagstaff, Arizona, for a series of geological lectures and field trips conducted by Eugene Shoemaker. 7 out of 9 of the Group 2 astronauts made it to the Apollo lunar program. Elliot C. died in a plane crash that was covered in episode 76, and Ed White died with Gus Grissom in the Apollo 1 fire. Jim McDivitt commanded the first Earth orbital flight test of the Apollo lunar module with the Command Service Module. This mission flew in March of 1969 as Apollo 9. Frank Borman flew on the first lunar orbital flight of the Command Service Module on Apollo 8. Jim Lovell flew as Command Module pilot on Apollo 8, and he became the first to fly a second Apollo mission as commander of Apollo 13. Tom Stafford commanded a lunar orbital test of the lunar module on Apollo 10. John Young flew with Stafford on Apollo 10. Young later commanded the successful Apollo 16 lunar landing. He also commanded the first space shuttle flight, STS-1, Columbia, on April 12, 1981. Pete Conrad commanded Apollo 12, the second lunar landing, and, of course, Neil Armstrong commanded Apollo 11, becoming the first man to walk on the moon. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.